Okay, this video is going to be about one-step conversions and how we use conversion factors in chemistry. Now, the first part is we have two equalities that we've been learning about in class. We've talked about how we have the mole, and the mole is basically a bundle, or the same way we would use a dozen is equal to 12. We know that the mole is equal to 6.02 times 10 to the 23rd particles. Okay. Now, the word particles is kind of just like the science word for things. Particles can mean several different things. It could be talking about an atom when you're referring to an element by itself. For example, if you're talking about atoms of carbon or aluminum, it could be referring to a formula unit. When you're talking about an ionic compound, such as salt, NaCl, which we know is ionic because it has a metal in it. It could be talking about molecules, which is when we're talking about covalent compounds. For example, sugar, or let's see, anything NO2, okay? NO2 is both nonmetal, so it's covalent. So all of these four words could be referencing to particles. But like I said, particles just means things. So if I had 1 mole of donuts, okay, I would have 6.02 times 10 to the 23 donuts. Now, if you need to know how big that number is, it's literally 602 with 21 zeros behind it. So that's 3, 6, 9, 12, 15, 18, 21. That's how many donuts you would have. Okay, that's a huge number. You would be able to fill the entire Earth, cover the entire Earth with donuts 5 miles deep. That's crazy. That's a lot of donuts. Okay, so we've got our conversion factor here. 1 mole is equal to 6.02 times 10 to the 23 particles. Now, that number has a special name, okay, and that name is going to be called Avogadro's number. Okay, now the reason why it's called Avogadro's number is because this Italian scientist, whose last name was Avogadro, is the one who determined how many particles there were in a mole. The way he did this was he said, if we look at two systems that have gases in them, okay, we're just going to have gases, and they're at the same pressure of 1 atmosphere, and they're at the same temperature, 0 degrees Celsius, then they should have the same number of particles inside them. And based on this assumption and a lot of other math, he figured out that that was that many particles. Now, when you weigh 1 mole, okay, we also know that our definition of the mole is the amount of matter, okay, in exactly 12.0 grams of carbon 12. Okay, essentially, he got a pure sample of carbon 12, exactly 12 grams, and calculated how many atoms there were. Okay, and that was Avogadro's number. So we know that 1 mole is equal to Avogadro's number, 6.02 times 10 to the 23 particles, but it's also equal to the molar mass, which we have found on the periodic table for elements. Okay, that's where we locate that. Now there's another video of how to calculate molar mass, and we'll do an example of that here. But if you need more help specifically with molar mass, go check out the other video on eClass. Okay, now let's use these conversion factors to actually do some converting. So if we're going to look at problem number 1, we want to convert, let's say, 20 grams of NaCl and we want to convert that to moles. Okay, the first thing we're going to start off with is our what's given to us. They give us this in the problem. This is given. Okay, and what we're trying to find is the number of moles. We're not sure what it is. So when we're writing out our work, okay, we always start off with our 20 grams of NaCl, and we're going to set it equal to X number of moles, because we're not sure. Okay, in the same way that you can write 1 dozen is equal to 12 eggs, right? We know that. You could say, well, 12 dozen would be equal to how many eggs? Okay, it's similar concept, just with moles and grams and particles and some new units that aren't quite as familiar to us as dozens or feet or inches, things along that nature. When we're going to do this, we're going to set them up as fractions, okay? Now, when we set up our problem as fractions, the key thing is the unit, or grams or moles, that's on the top of your fraction needs to be also present on the bottom of your fraction. So on the left side of my equal sign here, I have grams on the top, so I'll have grams on the bottom as well. And let's actually kind of move that over just a tad, if my eraser will work for us here. Okay, we're gonna move that over. Okay, and so I have moles over here. Now we know that our molar mass, which is measured in grams, is equal to 1 mole. So I'm gonna always put the number 1 beside mole. Now, what number goes here beside my grams? Well, that is an excellent question, and we know what number goes there because we know our how to calculate molar mass. Okay, the way we calculate molar mass is we're going to do that over here. So the molar mass of our compound, which is NaCl, is found by first splitting up the elements, counting how many I have. I do not have a subscript by them, so I just have 1 of each. We multiply them by their mass on the periodic table. Sodium is 22.99 and chlorine is 35.45. Okay, and when we multiply these through, we get 22.99, 35.45, and then we add both our totals together. And when we add our totals together, 22.99 plus 35.45, we get an answer of 58.44 grams per mole. Okay. So we're going to take that 58.44 grams per mole and we're going to set it equal here, which is essentially what I wrote. This is 58.44 grams is equal to 1 mole, which we have written here on the bottom of our fraction. Okay, we see that there. Now, with that being said, how in math do we solve for x when we have fractions? Well, we cross multiply. So the first thing I'm going to cross multiply is this direction. 1 times 20 is 20, and then I carry my units to have grams, NaCl, and mole. Okay, and I'm going to put the equal sign and I'm going to cross multiply in the other direction. In this case, because I have my variable, I'm going to keep those separate from what I'm multiplying and just show it in parentheses. So x number of moles times 58.44 grams. Now, in order to get x by itself, it's currently being multiplied, so I need to do the opposite. I need to divide by 58.44 grams on both sides in order to get my variable isolated and by itself. So when I look at this, my 58.44 grams on both sides cancels out, and then my grams cancels out on my left side. So when I do the math here, I'm going to have x number of moles is going to be equal to my units, are moles of NaCl. And when I do my math, I have 20 divided by 58.44, and I get 0.342 moles. And there you have it, your answer. Okay, so essentially, all you need to do is set up your fraction, cross multiply, and solve for x. Now, what if we use these number of moles and do something similar, but a little bit different? Let's work on a second problem. What if we want to take those 0.342 moles of NaCl that we have, and we want to know how many formula units that is? Are we going to do the same thing? Yes, we're going to use the exact same setup, but we're going to use a different conversion factor. So again, we start off with what's given to us. Our 0.342 moles of NaCl, and we set it equal to X number of formula units, which I'm going to abbreviate, okay, because that's a long word, okay, and I put it into my fraction. Because I have moles on the top of my fraction here, I'm going to have moles on the bottom as well. And anytime I write mole in the denominator of my fraction, put a 1 beside it, because all of my units are all of my conversion factors up here, these are my factors, okay, are all equal to 1 mole. So I have formula units on the top there, so I'm going to put formula units on the bottom of my fraction. Now, if we look back at our conversion factor, which one has formula units? Well, not the mole, we've already used that. Not molar mass, because molar mass is working with grams. But if we look at particles, we know from our discussions earlier that particles is a science word for things, which means we can talk about formula units dealing with particles down here in the problem below. So we will write our Avogadro's number, 6.02 times 10 to the 23. Okay. Now that we have our problem set up, all we need to do is cross multiply. So let's go ahead and do that. Cross multiply here. Now, when you're working with exponents, it's very important to make sure that you are typing things in your calculator correctly. So the way you would type this in your calculator, so calculator over here, you would put a parenthesis, because anytime you have a number with an exponent, you want to make sure it's in parentheses. You would put 6.02. There's a button on your calculator that has 2 capital E's, although some of your calculators may have EXP for exponent instead. This essentially replaces the times 10 part right here, and then you would put the number 23, okay? And we're going to multiply that by our 0.342. Okay, so that's what you would put in your calculator. So you should have your calculator in front of you. Remember, second semester chemistry is almost all math, so it's imperative that you have a calculator with you at all times. So 6.02 EE23 times 0.342 is going to give us an answer of 2.06 times 10 to the 23rd. And our units are going to be mole NaCl formula units. And I'm going to set it equal and multiply the other side. I have X number of formula units times my 1 mole. In order to get X by itself, I need to divide by my 1 mole here. By doing so, I notice that 1 mole and 1 mole cancel out, my moles cancel out, and my X number of formula units is equal to 2.06 times 10 to the 23rd formula units of NaCl. At the end, my units on both sides match up, so I know that I've solved my problem correctly and gotten the right answer. Okay. Furthermore, we are going to be using the same style using ratios and cross multiplication in the next video when we talk about how to do two-step problems to go directly from formula units to grams or particles to grams and skipping the step to the moles in between. Okay, so pay attention to that and go check that out.